All right, in this video I'm going to walk through doing, let me put this in 2D. I think I had drawn something in 2D. There you go. Remote elevation using a theodolite. So let's get rid of this right now. And don't worry about that. So basically you're going to set up over a point, call this point A. You're a decent distance away so that you can actually shoot. If it's too steep, you won't be able to shoot it. And in this case also, you sort of set up the instrument kind of high, so you're going to be looking up. And then what you'll do is you'll set up over this point, that point there, and then you're going to sight this point, the remote point, and then you're going to turn horizontal angle right. So you zero set it, and then you're going to turn horizontal angle right. So you're looking down at this one, right? And that's going to give you a horizontal angle. So you're going to, right, let's say right here, that's 55 degrees. Then you're going to measure this from this point to this point. And in the example I just wrote, it's 72 here. So let's just take that 72 and then field measure horizontal distance. So that's the 72. It has to be the horizontal distance, not the slope distance. And then you're gonna set up on this point. You're gonna backside to this one, right? And then you're gonna turn horizontal angle right again till you're collimated on this the same point. And you're going to write that horizontal angle down. And you can calculate this angle can be calculated 180 minus 55 minus 75, right? And it'll give you 50 degrees. And now that you have 50 degrees, you're going to use the law of sines. So the sine, or actually take the distance. So up at this angle, the sine of this angle, or this distance divided by the sine of this angle will be the same value for all of these. So you just use a little bit of algebra for that. So 72, blow that up a little. So 72 divided by the sine of 50 will equals, and let's just go over to here to Excel. So 72 divided by, and that's the sine of 50. You could actually put it right here. 50, enter. And instead of 50 there, we'll just write down that value for the cell. And then that gives you, then when you divide that, it'll give you 93.989. And that's going to be the same number for all of these. So you go to the next one here, Control C, Control V. So now we have, we did 50, we got that value. Now we're going to do, let's do this one since we're on this point and we're looking for this horizontal leg so we can calculate the height. So sine of 50, then you did the same thing here, 55, enter, and then sine 55, this would be here, enter. You just do the same thing, you multiply the sine of that angle times that common denominator right here. Should be, and I just wrote that equal, it could be actually, you get rid of that and go here, like that. Right, so you end up at 76.992. That's how you calculate that leg. Then if we're going back here, 76.992, and then in this case, that vertical angle here from the horizontal from the instrument, the vertical angle is 33. So there's 33, and then you just use the rise divided by the run. So x, which is the unknown, the height that we're looking for above the instrument, divided by 76.49 would be the tangent to 33. So we just go x equals tangent of 33 times 76.992, which I did here. Actually, let's go here. So it's this is tangent of 33 tangent. Then you have to put the radians in, otherwise it's weird. You want, if it's multiplying by tangent in degrees, tangent of 33 degrees, you have to put radians in there. If you don't, it's going to give you the tangent of 33 radians. Go figure. And then and then just multiply by that 76.992 that we had. And that gives you this dimension here, so 49.99. And if you look on this, I think I did the 3D, Control W. Maybe not. Look at 3D and see if I did. Yeah, there you go. That's it right there, I think. So this is the 33 degree out MA. So let's see what that is. 32.3, missed it. Out MA. That's 33 degrees. And this is weird, but that stopped early. But that's the total height is 49.999. So the calculation works, and that's the height above the instrument. If you needed to do it above the point somewhat on the ground, you could do that. If you needed, let's say you had a point here, up here, right, and you needed the distance between these two, you could just do the same thing. You'd just be taking, well, only if it would be vertical. Otherwise, you'd have to take a second horizontal reading too. Starting to get a little too deep, but that's typically how you see the example in maybe a book. I don't remember learning this. I do remember seeing it. So if you want to do it, that's how I would do it. And then, like I said, so if you had another point that was directly above it, let's say it was an insulator and you needed the height of the insulator, you knew the height insulator was vertical, a plumb, then you could just do, instead of 33, you take the 33, record that height there, and then let's say another one was like that. Okay. You have another elevation there. 41 degrees, 26 minutes, 34 seconds. Let's do that actually. I'm going to do this. 41 T, 41 degrees, 26 minutes, and 34 seconds. Control C, and then I'll take it into Excel. I'll show you how to do that. Control V. So if you had that was an angle, then you needed to convert it into decimals. There's a formula. I've got that. I've seen it, put it in a video not too long ago. You're going to go 41. You're going to separate it into 3 different columns. 26, 34. It's hard to keep these under 10 minutes. Equals, and then you know that's going to be 41. So this one's going to equals that. And then this one's going to equals this divided by 60. And then this one's going to equal this divided by 3,600. All right, and then you're going to go equals this plus that. Enter, and now you could do the same thing here. You could take this equals that, enter. Go this, so x divided by this is going to equal that, right? So you're going to go equals sine, no tangent gradients of this 41 close times this, no, times the distance, which we already just had, 76.99, enter. Now to give us 67.98. So I guess we could do this. And then we had the first one. That was the first height. I think, no. 49, this is the first height. So we go equals, let's highlight those. Those are our 2 elevations. Going to go equals this minus that, enter. 17.98. If we go back to this, 17.98. So you've calculated the height of an object or like something that was up in the air. And that's, like I said, only if it's plumb. If it's not plumb, you'd have to do 2 horizontal angles, 2 vertical angles, and then calculate the distance, the diagonal distance between the two. A little beyond the scope of this. I'm trying to keep it at 10 minutes. So hope that helps in your career, and thanks for watching.